Ladies and gentlemen, we cordially invite you to take the prescribed seats in the room because in a few minutes the event will be started. Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. May peace be upon us all. Shalom, Om Swastiastu, Namo Buddhaya, Salam Kebajikan, Rahayu. Good afternoon, ladies and gentlemen. First of all, let us pray and praise to our Almighty God. Because of His bless and mercy, we can come together without any obstacle here with healthy condition. I would like to say welcome to the Honorable Professor Dr. Edi Cahyono MSE as the Dean of the Faculty of Mathematics and Natural Sciences. as well as the all vice deans here. The Honorable, all the heads of departments, and also heads of study programs, as the Faculty of Mathematics and Natural Science of Universitas Negeri Semarang. Also, the Honorable Associate Professor Stephen Person, PhD, as Associate Professor in the Department of Computer Science of the School of Computing at the National University of Singapore. The Honorable Ms. Riza Rosita, SSE, MSE, as Head Section of Environmental Technology Security. And of course, welcome to all of today's participants who are present today in a hybrid manner, both online and offline. Ladies and gentlemen, my name is Monica Luishandauriastuti. It is wonderful and precious chance for me to be your master of ceremony on Thursday, 8th of June 2023. It is outstanding seminars. So, welcome to Studium General with the theme Strengthening Faculty of Mathematics and Natural Sciences Partnerships to Support UNNES as Legal Entity State Universities. Well, ladies and gentlemen, please allow me to read the agendas for today's event. The first, the agenda is the opening session. The second is singing the national anthem of Indonesia, Indonesia Raya. The third agenda is the speech from the Dean of the Faculty of Mathematics and Natural Sciences of Universitas Negeri Semarang, and will be followed by signing of implementation of arrangement. The fourth agenda is the main session, which is Studium General, and the final agenda is the closing session. Ladies and gentlemen, the first session is opening. So let's open today's seminar by saying basmalah together. Hopefully, this event will run smoothly. The next agenda is singing the national anthem of Indonesia Raya. Ladies and gentlemen, please rise. To Professor Dr. Edi Cahyono MSI, time is yours.
Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh. Alhamdulillah, alhamdulillah wa syukurillah la haula wala quwata billah. Pertama-tama saya menyampaikan selamat datang, salam hormat pada Ibu Risa Rosita SSMSI, juga Associate Professor Stephen Bresson, it's true? Bresson? Yes, beliau dari Perancis. Ya, jadi agak ada dengungnya. Ya, seperti bindeng ya kalau bahasa kita ya. Uh, Bapak Ibu, Bapak-bapak ya, nggak ada ibunya, Wakil Dekan, Kajur, kemudian juga Bapak Ibu pimpinan di jurusan, Bapak Ibu dosen, mahasiswa-mahasiswa yang saya banggakan, yang berkenan hadir pada kegiatan kita kali ini. Tentu kita menyampaikan rasa syukur kehadirat Allah Subhanahu wa taala bahwa siang ini kita bisa bertemu dalam suasana sehat, memulai dengan kegiatan akademik dalam Studium General. Jadi satu hal yang barangkali istimewa, sehari kita bisa menyanyikan lagu Indonesia Raya 3 kali, seperti minum obat ya. Setiap acara selalu ada Indonesia Raya, itu menguatkan kita sebagai suatu bangsa, ya, agar lebih cinta tanah air kita. Ya. Nah, kemudian yang ingin saya sampaikan, saya ingin mengenalkan pada tamu-tamu kita yang sudah hadir sejak kemarin. Kita memiliki berapa program? 13 ya. 13 program studi, study program, 17 study program from mathematics department, biology department, chemistry department, science education department, and computer science department. Ya. Ada 17 program studi dan 13 program studi, dan mulai tahun ini nanti kita akan bergabung 7 program studi lain, yaitu pasca sarjana. Jadi nanti 13 itu berkurang satu ya, dari 14 kurang satu, yaitu farmasi nanti akan pindah ke fakultas kedokteran, tapi kita kedatangan dari 7 program studi. Nah, harapan kita kegiatan ini bisa menjadi suatu pemicu atmosfer akademik yang baik, bahwa visi kita, salah satu visi kita tadi apa? Visi UNNES yang disampaikan Pak Rektor pada upacara Dias tadi adalah menjadi universitas bereputasi dunia, pelopor kecermerlangan pendidikan yang berwawasan konservasi. Bereputasi dunia, salah satu jalan yang kita tempuh adalah ini. Kita akan berkolaborasi, NUS dari Prof. Stephen ini bukan universitas yang main-main. Peringkat 19 dunia. 11 dunia, 11 dunia, dan 3 Asia. Bayangkan ya, Indonesia nomor berapa ya Pak Arif ya? Belum ada yang masuk ke 100, di bawah 50 belum ada ya. Jadi kesempatan Prof. Stephen datang ke sini mudah-mudahan bisa dimanfaatkan teman-teman dari jurusan ilmu komputer, dari jurusan fisika yang berkait, mumpung ada. Ini yang kita akan semakin banyak riset-riset kolaboratif internasional. Kalau bisa ngajak mahasiswa ke NUS ya. Saya pernah merasakan 3 bulan di sana, luar biasa atmosfer akademiknya, alhamdulillah masuk di merasakan atmosfer akademik di NUS. Juga Ibu Risa Rosita ini dari Head Section of Environmental Technology Security ITS dari Biotrop ya Bu, Semio Biotrop itu kemarin kita ngobrol-ngobrol, ada beberapa lab, satu semester insya Allah bisa menampung sekitar 15 mahasiswa MIPA. Silahkan kalau untuk berprigel, berperigel itu bisa diakui dengan 20 SKS, riset dan PKL. Nah ini nanti mungkin Pak WD1 bisa menindaklanjuti, tentu saja dipersiapkan kerjasamanya. Nah kalau ke NUS mungkin kita lebih banyak ke riset kolaborasi, kolaborasi riset. Nah ini yang barangkali bisa kita tawarkan. Harapan kita setiap jurusan punya mitra-mitra internasional yang benar-benar aktif ya, tidak sekedar signing tapi juga ada isian dari kegiatan-kegiatan yang kita lakukan. Jadi ada Prof. Stephen, ada Ibu Risa, saya pikir kita akan punya arah untuk riset-riset kolaboratif kita. Ini yang dapat kita sampaikan, ini adalah rangkaian dari acara DIES kita yang ke-58, yang tinggal satu kegiatan lagi besok malam, yaitu apa saudara-saudara? Wayang ya. Ketopraknya saudara nonton enggak? Nonton ya, berarti nonton Pak Edi juga ya. Kita masih ada kegiatan wayang, itu bahasa Inggrisnya apa Pak Arif? Apa? Puppet ya, puppet and tomorrow night ya. 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 Oh, puppet shadow. Wayang kulit. Oke, mudah-mudahan ini bermanfaat. Silahkan bertanya yang banyak, kesempatan dengan native speaker, teman-teman mahasiswa latihan, tidak usah malu ya. Seperti Mbak pembawa acara itu bahasa Inggrisnya luar biasa ya. Mudah-mudahan diikuti mahasiswa yang lain supaya kita siap go internasional. Billahi taufiq wal hidayah. Assalamualaikum warahmatullahi wabarakatuh.
Well, thank you to Professor Dr. Edi Cahyono, MSc, for the opening speech. To Mr. Dean, please remain at the stage because our next agenda is signing the implementation of arrangement. Yes. Ya.
Nggak usah nunggu jenengan tayang, pokoknya lanjut aja,
Ya.
itu urusan mereka, biar nggak nunggu lama ya
Okay.
bedanya.
We also invite to the stage our keynote speakers. Please come to the stage, Associate Professor Stephen Person and Ms. Risa Rosita. We also invite all vice deans to come to the stage. Next, we take some photos to document this moment. Please documentation team to take the photos. Thank you. Dan untuk seluruh peserta dimohon bisa berdiri untuk dokumentasi sesi dokumentasi.
안녕하세요. Yeah. Thank you.
Thank you very much, and thank you to all of the welcoming guests. For all invited guests, if you have other activities, you may leave. Well, ladies and gentlemen, we are going to the main agenda, that is the Studium General, with our most outstanding speakers, Associate Professor Stephen Person, PhD, and Miss Risa Rosita, SSE, MSE. This session will be led by our moderator, Miss Lutfia Nurhadianti, SPD, MPD. Before that, let me briefly read out her curriculum vitae. She's a lecturer in Biology Education Study Program, Universitas Negeri Semarang, who was born in Kebumen on 2nd July 1989. Her address is at Karanggayam, Kebumen, and you can contact her at her email address lutfiahadianti@mail.unes.ac.id. For her educational history, she took her bachelor's degree in Biology Education at Universitas Negeri Semarang and her master's degree in Biology Education at Universitas Pendidikan Indonesia. Well, ladies and gentlemen, please welcome Miss Lutfia Nurhadianti, SPD MPD. Okay, to Miss Lutfia, the floor is yours.
Okay, yeah. Let me sit down first. Okay, good afternoon, everyone. Thanks for the MC for the introduction, and I will be the moderator for this event. And we gather here in a Studium General Strengthening Faculty of Mathematics and Natural Sciences partnership to support UNNES as a legal entity state university. And today we will have two speakers. One is from Indonesia and another is from other country. Yeah, and Associate Professor Stephen is from Singapore. And the topic of this event, it will be related to the computer and also the biology. So let me check the biology student here. Is there any biology student? Raise your hand, please. Okay, good. And computer science student, raise your hand. Okay, 1,000. 1,000, because I multiply one person with 25 maybe. Well, okay. Without further ado, I will let the speaker to come to the stage. Associate Professor Stephen Bresson, yeah, and also Miss Risa Rosita. Yeah, please welcome and give applause to our speakers. Yeah. Yeah, welcome Miss Rosie and also Stephen. Yeah, and in around 2 hours, we will have a seminar related to the computer and also biology. And the first speaker will be Stephen. But because before we start to the first speaker, yeah, I will read the curriculum vitae of Stephen Bresson. And Stephen Bresson is an associate professor in Department of Computer Science of the School of Computing, SOC, of the National University of Singapore. Stephen is track leader for Maritime Information Technologies at NUS Center for Maritime Studies. He is also affiliate professor at NUS Business Analytics Center and faculty. Right, Stephen? And also, he is also a member of the Image and Pervasive Access Lab. And in 1990, Stephen joined the European Computer Industry Research of Bull, yeah, in Siemens in Munich, Germany. Yeah, in 1994, he was appointed site leader of the database platform project and principal investigator and work package manager for the European IDEA Esprit project on intelligent database. And the research interest are on information integration, data management, and data analysis. So it will be great for you, the computer science student. After this, please note and also give attention to the explanation from Stephen. Yeah, and the selected publication is the first, generating fake but realistic headlines using deep neural network access. And the second is anomaly detection and identification scheme for VM live migration in cloud infrastructure. Tian Huang is one of the author, maybe, yeah. So please welcome Stephen Brisson to give the explanation and also the presentation. Yeah, time is yours, Stephen.
So good afternoon, everybody. Can you hear me in the back? Okay. So I didn't give you my date of birth. I noticed the MC was telling when we were born. Actually, I was born on the 4th of March, 1965. So your anniversary is not too far from my own birthday. And I just revealed I'm 58 years old as well at the same time. So, Prof. Eddie, yes, you mentioned the standing of NUS in the recent ranking. And I would like to highlight that the reason why NUS is ranked high this time is also because we are collaborating with our partners around the world, but also in the region. So you did play your role, and Dr. Zenal, with whom I've been working for more than a year now, played your role in the success of NUS. So we'll be happy to also return the favor and continue collaborating with you. For the students, you mentioned that there are opportunities for collaboration and growth together. So that's actually the main reason why I'm very happy to come here. I asked Prof. Eddie and Dr. Zenal to help me find out the best, most hardworking students in this audience who are interested in doing research. So those of you who are doing research and have very good academic standing, then we're going to discuss the possibility maybe to do internship in Singapore, or to collaborate with your lecturers here on some research projects. So this is the reason why I'm very happy to be with you here, so that you understand what we are doing, and maybe you get interested and you talk to Dr. Zenal, and he's going to tell you what it takes to get an internship or a project with Singapore. So I know it's your exam time, so work hard so you get very outstanding results, and then we'll be prompted to make you an offer. So today I want to talk about physics-informed machine learning. Maybe we can show the slides. Yeah, okay. Let me open this. So I understand that the audience is mixed. I had prepared maybe a rather technical presentation. I will not go into the technical details, but they are on the slides if you're interested. I will share the slides if you want to take a look at them. And at the end, I will give you some references to our publications if you want to go into the details and check out the publications. So you may have heard this quote from Isaac Newton in his book, the book where he formulated the main physics law, the main laws of classical physics, the laws of motion, the law of universal gravitation. He, talking about his book with one of his physicist friend, he said, if I have seen further, meaning if I have done what I've done that other couldn't do, so if I'm famous today, it's because I am standing on the shoulders of giants. What does it mean? It means that although he is the famous guy, he is the guy that we remember, he would not have done this alone, and he had to rely on the researchers, the scientists that came before him and that paved the way to his findings. So this is very important from many points of view. I mean, you guys are students, and basically most of your activity is to understand what the previous scientists and engineers have done so you can move further and do your part. You know, maybe it's 80% of the old knowledge and 20% of the new knowledge that you guys are creating. So we are standing on the shoulders of giants. Now, if I come fast forward to today, or to, you know, our decade, you remember in 2016, maybe you heard in the news that there was an artificial intelligence that was able to beat a professional player at the game of Go. I don't know if, how many of you are playing Go or chess, maybe? Chess, Go? No, you know these games? Go is a very Japanese game, right? Yeah. So the computer is notably difficult, right, to play Go. The computer was able to beat the professional player. The algorithm was written by scientists at Google. Then we had a computer based on neural networks. The computer scientists in the room may have heard about neural networks, who was able to play chess and work fast. Also, we had this ChexNet, which was able to, I understand there are biologists here, so maybe some people are also working on medical biology. So the computer was able to classify the radiography better than the professionals, faster than the professionals. So this is pretty good. AlphaFold, this is biology, right? Was able to predict the structure of protein. So you have an artificial intelligence that can assist the biologist to design molecules, proteins, etc. And of course, recently we had ChatGPT. Can you raise your hand if you have tried ChatGPT? Raise eye, it's good. So I have a question to you. How good is the Indonesian language of ChatGPT? Is it okay? Is it acceptable? Yeah, okay. So I play with ChatGPT as well, right? Okay. Actually, there's nothing wrong playing with ChatGPT. If you do, for instance, if for your test or your assessment, if you do, just indicate it. You know, it's scientific integrity. We are on the shoulders of giants. So of course there are things that we are borrowing from others. But science requires that you tell that you are borrowing from the others. You give the reference. You say, I'm thinking this and I'm borrowing this from the other scientist or from ChatGPT or etc. The problem with ChatGPT is that it doesn't do it himself. It doesn't give the reference. We don't know where the knowledge comes from. Okay, so I tried to use another OpenAI tool, which is called DALL-E. If you go to the website of OpenAI, where you find ChatGPT, you ask question, give you an answer, but DALL-E draws picture. Have you tried DALL-E? You can draw a picture. You just say what you want, and the software is going to draw a picture for you. So here you have 3 examples. I wanted to have a picture that illustrates robots standing on the shoulders of scientists to talk about the fact that artificial intelligence is the result of a lot of science and engineering. And I asked the software, and in half a second, it drew the picture that you see on the right side here. This is not a real photograph. This is not something that I created. The artificial intelligence created that picture on the right side. Then I said, well, maybe artificial intelligence, of course, is built by engineers and scientists, but it relies on a lot of data. You build a model of whatever you are studying, maybe biology, maybe chemistry, maybe physics, by providing a lot of data to the artificial intelligence. So I asked DALL-E, can you draw a picture of a robot symbolizing artificial intelligence on the shoulder or on a heap, on a stack of data? And this is the picture in the middle. That was generated by the artificial intelligence. Again, not a real photograph, not a painting by a human, a picture generated by artificial intelligence, by the machine. Sorry. And then I said, well, yes, but all this is possible because of the technology. The artificial intelligence is working because we have faster and faster computers. So in fact, the robot is standing on the shoulder also of other robots. So I asked DALL-E, can you draw me a picture to illustrate my slide? And then you got this picture of a robot standing on the shoulder of other robots, right? So once again, these three pictures are completely generated by the computer. Go to OpenAI and you can play with that, right? DALL-E is free. You just log in, giving your Google account or whatever, and you ask the system to draw pictures. Anybody has used DALL-E before to draw picture? No? Only ChatGPT? So you should try DALL-E as well. Okay, I'm going to go to the next slide. But the reality is that all this is again possible only because humanity has accumulated a lot of knowledge. So one of the questions I want to discuss with you today is if you build a machine learning model, so an artificial intelligence model for your problem in physics, in mathematics, in engineering, in biology, of course, maybe you can provide a lot of data, but you also want to be able to tell the machine that you already have a lot of knowledge. You don't need the machine necessarily to rediscover everything from the data. You want to impart some of the knowledge. That's why I also ask, can you draw a robot standing on a heap of knowledge? This is what I'm trying to do, to make sure that the machine learning is going to be able to benefit from the scientific knowledge that we have. So this is the research question that my group is working on. If you have a machine learning model, a neural network, we also have Gaussian processes, we have all kinds of regression devices. How can I, in addition to doing the data analytics, if you want, the statistics about the data, how can I tell the system, this is the physics knowledge, this is the biology knowledge, this is the chemistry knowledge that you should know before or at the same time you process the data. M. Kaniadakis proposed a classification of 3 ways you can tell a machine learning model of the knowledge of the underlying domain. So one thing that you can do, since the machine learning is looking at the data and trying to build a model of the data, maybe you can try and modify, select, complete the data to inform the system about the knowledge. I will give you some examples later. So the first part, the first possibility is what we call observational bias. So we're going to take the data and bias it in a way that it really indicates a certain knowledge. So for instance, if you know that there is some kind of cyclicity, maybe you're looking at seasonal data, you know, some ecosystem which is working with the seasons, winter, summer, etc. Well, then you can create cycles and repeat the data so that the system understands that there is a cycle. Okay, so this is the first possibility. The second possibility is to add what we would call learning bias. This is the most obvious, but the most difficult because it requires to look at the underlying mathematics of the system. So basically what you want, I take again the example of cyclicity, of periodicity. You want to tell the system when it's learning whatever function, let's say the system is learning a function, like in math, you know. Whatever function you are learning, it must be a periodic function. So you have to add this mathematical condition to the learning process of your artificial intelligence. And then you turn, I don't know, do we have mathematicians in the room? People from the math department? So we turn to the math department and we ask them, how can we do that? And probably they will come back to us and talk about things like Lagrangian functions and things like this, devices like this, where you can add constraints. Oops, sorry. I have a small problem here. Yeah, it's okay. It's okay. So you can change the data, you can tell the math to the system, and the third possibility is that you can actually build the architecture of your system in such a way that it embeds the properties that you want. And we call this inductive bias. So you can change the data, you can change the learning, or you can change the architecture. I will show you some examples later. These are the three categories of bias that you can give. And actually, you don't have to choose. You could give the three of them or in many different ways at the same time, right? So if you are a scientist and you want to use artificial intelligence in your domain, and you don't want to forget everything that you know and just look at the raw data, then you need to think about these three methods to make your artificial intelligence at the beginning at least as smart as you are. You know, there's no point to start behind you. You can start at the point where you already are. Oops. Okay. Okay, I have a technical problem here. Okay, maybe we're going to try like this. Are there physicists in the room? Do we have physics people here? Okay. So I apologize. I'm going to try and explain things that you probably know very well, better than me. And actually, maybe I make a small parenthesis. This is the time for me to also explain that multidisciplinary research is really the modern research. So I'm going to talk about physics. I'm going to talk about classical physics. I'm going to talk about quantum physics. I'm going to talk about astronomy. I'm going to give you examples in these three fields. I have no idea what I'm talking about. I actually am working with physicists, quantum physicists, people from the astronomy department, and they explain to me the science, and I do the computing for them. So First of all, I apologize to the physicists if I say something wrong. Please let me know. But for the students, understand this as an interesting message. You can work with computer scientists if you are a biologist. If you are a computer scientist, you can work with mathematicians, with physicists, with economists, etc. This is modern science, multidisciplinary. So I'm very happy to be a host of this faculty of many sciences, right? If you look at all the departments that you have, you're covering all these domains. So this is very exciting. So the first application I want to show you is an application to Hamiltonian systems. So if you remember, or if you have taken a physics class, a Hamiltonian system is basically pretty much any mechanical system that we know about. And without going into the nitty-gritty details because of the diversity of the audience and the time, let me just try and summarize. Again, let me know if I'm wrong. Hamiltonian system essentially says there is a conservation of energy. So you have, maybe the potential energy and the kinetic energy. The potential energy depends on where you are. If you put some object here before you let it fall down, well, it has the potential energy. And this potential energy, maybe if I simplify, is going to be transformed into kinetic energy. It's going to move and fall down, right? But the total energy is conserved. It's always the same. So now you want the machine learning to learn to make a model of some physical system. The challenge is, can you tell the machine learning, well, I know the system is Hamiltonian, and I know the energy is going to be conserved. How can you do that? Normally, the machine learning just look at the data, position, momentum, position, momentum. But what you can do is, for instance, look at Hamilton's equations and put them as conditions in the learning function of your machine learning system. So then you need to find a physics friend or a mathematician friend to find the formula, right? That's what I did. I called the physicist. I said, can you figure out how to do that? And they gave me the formula, the math formula. And I put it in my computer, and then it works, right? Well, if you remember, you can also maybe change your data, because those Hamiltonian systems, especially the standard mechanical ones, they have a nice property, is that the momentum, the potential energy only depends on the position, and the kinetic energy only depends on the momentum. So it's actually the sum of two parts, right? Without going too much into the details. So I am going to look, maybe this is the system I'm trying to learn, right? This pendulum. And I'm going to look at position, momentum, position, momentum. I'm basically observing the system. And what I want is to learn the picture on the left side here, which tells me everything about the system. This is a model of the system. The color represents, for those of you who know, the Hamiltonian function value. Okay, so I want to do a regression of the vector field of these positions and momentum to learn the Hamiltonian, and then I'm going to be able to predict the system. So this is going to be a machine learning algorithm that finds a complete model of the system. So I could, if I know the system is separable, let me jump to this. Every time I observe a vector, I know that the x component is going to be the same for every x value. And I know that the y component is going to be the same for every y value. So if I observe the two data in the two vectors in black, then I can create new vectors in green. So I can have more data than I have observed because I know that the system is additive. Another way is I could say, well, if the system is additive, the second partial derivative is going to be 0. Again, you can ask your math friends what I mean by that. But for the computer scientist, once I realize that, I just put that in my computer. I say, okay, learn something, but make sure that the second derivative is 0. And then you improve the learning. Or actually, you can do even something smarter, which is the inductive bias. You can say, well, if the Hamiltonian function is the sum of 2 functions, then instead of having 1 neural network, why don't I have 2 neural networks and I add them up? I just say, this is the sum of 2 functions. You see, sometimes it's as simple as that. You say, it's the sum of 2 functions, you have 2 neural networks. Okay. So this is an example. If you are working with AI in biology, or in physics, or in economy, or in other domains, you have to go through the same thinking process. Can I include observational bias, learning bias? Do I know some laws that would help the system to learn? Or can I transform it into some inductive bias? We have done the same thing in quantum physics. So maybe some of the physicists in the room have looked at quantum physics. Basically, the Ising model, a model of many particles, atoms, the way I look at it is like a graph. You know, you have particles, you have atoms that are interacting. So if we are next to each other, maybe we interact with each other, you interact with your neighbor, and the interaction is going to be transitive, right, eventually. So we need to model this interaction. And once again, what we do is we look, can we do it with observational bias, learning bias, inductive bias? Well, in this case, we used again neural networks. Each of the neural network represents some quantum energy level. So they are trained using the learning bias, but they each interact with each other thanks to inductive bias. So you have to, you know, it's kind of alchemy. You have to find a way of introducing the right bias based on your knowledge as a designer of the background domain. Let me tell you to conclude, I think I have 5 minutes approximately, less than 5 minutes. Another story. I also worked with the Department of Astronomy because I wanted to understand how much you can really learn from data and whether eventually, without our help, so contradicting some of the things I said before, would it be possible that the machine replace the scientist? You know, no more job for us. Then we have to look back at what scientists have done in the past. Were they able to create knowledge just from data? We will not have the philosophical discussion now, or we can have it offline if you want. There is such a thing as a thought experiment, you know, where you're thinking in your head. It's not looking at data just. So maybe that's the power of intelligence. But we wanted to see whether, can we go back to the slides? Yes. Whether we could reproduce, and we're still working on it, the invention of the laws of the motion of planets by Johannes Kepler. Johannes Kepler is famous for having discovered how the planets are orbiting. So what did Johannes Kepler knew? He knew that Copernicus said the planets in the solar system are orbiting around the sun. It's a heliocentric system, right? This is knowledge from the 16th century. Then people starting collecting observations of Mars, of the sun, and they put together a lot of books where you just had, you know, daily sightings of the stars and the planets and the sun. But let me see, in the 17th century, Tycho Brahe, he was a scientist working for a German emperor. He put together very, very good observations of Mars. So he built a device so that the data I know my colleague Riza is collecting data for biodiversity. He did your job, but looking not at biodiversity, but at the stars. And he wrote down all this data. Johannes Kepler, who was his assistant and successor, transposed and wrote and published all this data. And from the data and the fact that the system is heliocentric, he was able to come up with a model where the orbit of Mars is an ellipse. He could have done otherwise. He could have said, well, it's like something going around a circle and then smaller circles and then smaller circles, etc., right? But actually, he had the idea that it was an ellipse. So what we did, we used this software called AI Feynman. AI Feynman, you give data and it's going to give you the equation. Equation, right? Like log, sinus, etc. So we gave the original data, which we transcribed, of the sightings of March, and AI Feynman was able to do the same job as Johannes Kepler 500 years ago. It came out with the equation of Mars. So this is scary, right? Maybe science is going to be done partly or fully by the artificial intelligence. So to keep up to date, we need to understand AI and we need to understand science. So to conclude, I showed you how to inform machine learning of the physics, but I have done work in other domains. Classical mechanics, quantum physics, astronomy, but also in math. So you can do mathematics with those machine learning. You just have to tell the system of the theorems that you know. Graph theory, differential calculus, variational optimization, fluid mechanics, if there are some engineers in the room, environmental science. So one very nice system to study, the biologists in the room may know about it, is the predator-prey model. Have you heard about the predator-prey model? So you have wolves and rabbits in the wood. The wolves are eating the rabbits, but if the wolves eat too many rabbits, then there's no more food, so they start dying, and the rabbits start growing again. But when there are many rabbits, the wolf can eat them and grow again. So it's a competition like this, right? So these are the kind of models we are studying. We did also economy. I know there are some people interested in energy and green energy and so on. We looked at economical models, which also have differential equation that we can put in the machine learning. And finally, we're looking at linguistics. I don't know if many of you are interested in linguistics here, but we are trying to teach a system to answer questions actually in Malay for Singapore, in Singapore Malay. But we want the system to know about the grammar, the syntax, and all the linguistics rules of Malay. So what I told you about today, you can apply to your own discipline, right? And remember the message, collaborate among each other. The modern science is probably going to be multidisciplinary. I will share my slides with the committee so you can take a look at the different papers and references that I have. Thank you very much.
Okay, thanks, Stephen. It is very interesting topic, yeah. And from Stephen's presentation, we know that you, as a biologist, cannot work alone, and also for you.
All right, thank you. So, good afternoon, everyone. Okay, the Honorable Dean of UNNES, Vice Dean, research person, lecturers, and also students. So, kindly first, I would like to ask permission to Prof. Stefan because I will use Bahasa to present my slides because it so relates to our national program. So it will be easy to share the knowledge using Bahasa. Yeah, Thank you. Oke, di sini saya akan mencoba untuk memaparkan mengenai Biotrop Profile dan potensi magang, karena diminta untuk mendiseminasikan kegiatan magang yang telah berlangsung dan sedang berlangsung di Biotrop. Saya sendiri adalah Head Section of Environmental Technology Security di Biotrop. So, Biotrop adalah salah satu litbang yang ada di bawah Kemendikbud-Dikti, biasanya disebut sebagai Pusat Regional Tropical Biology in Southeast Asia. Biasanya dikenal sebagai pusat pengelolaan keanekaragaman hayati berkelanjutan yang bereputasi baik di Asia Tenggara. Jadi ini merupakan goal besarnya kami untuk 5 years development Biotrop, seperti itu. Jadi visi di tahun 2022 hingga 2027 yaitu yang tadi sudah disebutkan ya, menjadi pusat pengelolaan keanekaragaman hayati di Asia Tenggara. Sedangkan untuk misinya yang pertama adalah menyediakan produk dan teknologi inovatif dalam mendukung pendidikan dan juga ilmu pengetahuan, tentunya tidak hanya di nasional tapi juga di regional, untuk mempromosikan pendidikan sains terapan dalam pemanfaatan berkelanjutan keanekaragaman hayati, membangun sumber daya manusia yang berkompeten terkait pengelolaannya. Ini adalah main strategies dan juga flagship programs. Jadi kami program ini terkait yang pertama yang ada di divisi saya yaitu Save Biodiversity for Future Generation. Kemudian juga ada Biodiversity Ranking and Database from Mountain to Ocean. This is for another section. Kemudian ada Agro-Eco-Edutourism, School of Biodiversity, Climate, Energy, and Environment Literacy of Biodiversity, Educational Model, Biotechnology Engineering, and Institutional Governance and Human Resource Development. Untuk key point-nya sendiri, output-nya yaitu memperoleh model pendidikan alam dan keanekaragaman hayati buatan manusia, di mana proses belajar mengajar di dalam dan di luar kelas itu saling mendukung satu sama lain. Selanjutnya, penerima manfaatnya tentunya kontribusinya diharapkan dapat menghasilkan sumber daya manusia yang kompeten. Nah, sumber daya ini berarti baik untuk mahasiswanya maupun dosennya, masyarakat, guru-guru, ataupun siswa, seperti itu. Caranya melalui pengembangan model pembelajaran kreatif terkait keanekaragaman hayati. Sedangkan impact-nya yaitu adanya pengakuan Biotrop sebagai pusat pengelolaan keanekaragaman hayati yang berkelanjutan di regional. Berikut adalah struktur organisasi kami. Ini banyak ya tabelnya. Jadi fokus saja pada yang kotak hijau ini. Oke. Dalam kotak hijau ini ada 4 kelompok section atau bisa disebut sebagai divisi yang ada di Research Department, Science Innovation Technology Department atau SITD. Itu ada Dr. Hari Imanto dan juga ada saya, di mana Pak Hari ini dia membawahi 3 laboratorium. Yang pertama adalah Remote Sensing and Ecology Laboratory, Weeds and Invasive Alien Plant Species, dan Herbarium. Sedangkan untuk saya sendiri ada 4 laboratorium. Yang pertama Biosystem Landscape and Management Laboratory, Entomology Laboratory, Phytopathology Laboratory, and Environmental Laboratory. Honestly, my master is not biology but biotechnology, soil biotechnology and environmental. Kemudian untuk departemen yang ada di pelatihan, kita biasanya menyebutnya sebagai Human Center Innovation Department atau HCID. Di sini ada 2 section, yaitu ada Dr. Romi Ardiansyah yang membawahi 3 laboratorium, yaitu yang pertama Biotechnology Laboratory, Tissue Culture Laboratory, dan Aquatic Laboratory. Kemudian ada Bapak Slamet Widodo Sugiarto, beliau membawahi Remote Sensing and Ecology Laboratory, Natural Product Laboratory, and Hydroponic. So go back to previous slide. Di Seameo Biotrop ini ada 2 skema magang. Yang pertama itu ada magang reguler dan juga ada magang MSIB, magang bersertifikat dari Kemendikbud. Di sini saya memberikan beberapa keuntungan dan kelemahannya ya. Untuk magang reguler minimal dilaksanakan 3 bulan. Nah, untuk prosedurnya ini, jadi tiap-tiap universitas mengajukan surat usulan magang ditujukan untuk Direktur Seameo Biotrop, nantinya oleh HR itu akan diproses ke masing-masing head section untuk di follow up. Kemudian materi magang reguler ini menyesuaikan proyek dan aktivitas section. Nah, Seameo Biotrop ini ada 3 kegiatan utama. Yang pertama penelitian, pelatihan, dan ada diseminasi informasi. Seperti itu. Jadi untuk peserta magang reguler, mereka akan diacak untuk aktivitasnya itu meliputi 3 kegiatan. Seperti itu. Kemudian bahan kimia kebutuhan magang menyesuaikan kondisi section. Jadi apa yang ada di lab menyesuaikan dengan kegiatan. Selanjutnya supervisornya itu biasanya host atau manager. Untuk MSIB biasanya dilaksanakan selama 4 bulan, lebih lama dibandingkan magang reguler karena sudah ditetapkan oleh Kemendikbud. Berdasarkan hasil seleksi MSIB Batch 4 yang sedang berlangsung, ada 2.500 pelamar yang hanya dipilih hanya ada 60. 60 itu meliputi 4 sub bidang magang. Bidang magang yang saya ampu yaitu pengelolaan sumber daya lahan suboptimal. Kemudian ada juga yang terkait manajemen biodiversity, sub bidang magang yang lain. Kemudian ada yang terkait pengelolaan laboratorium lingkungan untuk uji servis. Dan ada satu lagi mengenai bioteknologi. Kemudian materinya itu terdiri dari 20 SKS, tadi ya 4 sub bidang magang, dan bahan kimianya sudah dianggarkan. Jadi beda karena memang ada pagu dari anggaran DIPA dari Kemendikbud untuk mensupport yang MSIB bersertifikat. Selanjutnya pengajarnya itu adalah mentor dan ada pengajarnya juga. Oke, di sini saya akan mencoba memberikan gambaran kepada audiens tentang ITS program section saya yang telah dilaksanakan tahun sebelumnya yang terkait program Save Biodiversity for Future Generation. Nah, kegiatan ini menyesuaikan dengan Renstra tema 1, Renstranya Seameo Biotrop, yaitu untuk memperkuat dan menginisiasi kolaborasi nasional, memimpin dan berpartisipasi dalam kegiatan regional, nasional maupun global, membangun citra Seameo sebagai daerah organisasi pilihan untuk melaksanakan kegiatan dan program yang relevan dengan SDGs. Kemudian Renstra tema kedua yaitu program keunggulan dan relevansi SDGs, terutama dukungan untuk area hasil. Oleh sebab itu di Biotrop saya mempelajari tentang lingkungan, bagaimana mengelola merestorasi lahan yang sudah rusak dengan menggunakan mikroba-mikroba yang potensial. Selanjutnya untuk Renstra yang ketiga yaitu terkait kemitraan strategis, keterlibatan pemangku kepentingan, dan dukungan berkaitan dengan area hasil utama, seperti kolaborasi yang sudah dilaksanakan dengan UNNES. Kemudian Save Biodiversity for Future Generation ini tujuannya adalah untuk transfer pengetahuan melalui kegiatan promosi dan sosialisasi pentingnya menyelamatkan keanekaragaman hayati kepada generasi muda, baik nasional maupun regional. Meminimalisasikan penurunan atau hilangnya keanekaragaman hayati yang disebabkan oleh faktor alam dan juga manusia, mencari, membimbing, mempersiapkan, dan memperkenalkan definisi keanekaragaman hayati, mengapa penting untuk melestarikan keanekaragaman hayati, bagaimana melestarikannya, disiplin ilmu apa saja yang dapat mendukung kegiatan konservasi, efektivitas penerapan teknologi, dan aksesibilitas untuk pemanfaatan keanekaragaman hayati secara berkelanjutan. Adapun aktivitas yang sudah dilaksanakan tahun sebelumnya yaitu kajian, kita sebut penelitian atau kajian mengenai pengembangan prototipe pestisida organik. Jadi di sini selain dari saya sebagai leader research juga melibatkan mahasiswa dan employee yang ada di Seameo Biotrop. Di sini luaran yang diharapkan adalah adanya satu alat produksi pestisida organik, satu prototipe pestisida organik untuk pembelajaran biodiversity, dan satu modul pembelajaran. Mekanismenya biasa ya, metode pastikan ada tahap awal, menengah, hingga akhir. Seperti pembuatan pestisida organik, ada perakitan alat dulu, kemudian ada pembuatan asap cair, pengemasan, kemudian analisis kandungan pestisidanya, kemudian pembuatan isolat fungi yang menyebabkan penyakit atau kita sebut patogen ya. Jadi ada sampling komoditi kebun sekolah yang terserang fungi patogen, kemudian kita isolasi dan kita identifikasi. Selanjutnya kita uji bagaimana efektivitas pestisida organik tersebut dalam melawan fungi atau bakteri patogen tersebut. Lalu dilakukan pengamatan dan pembinaan terhadap penerima manfaat. Berikut adalah proses terkait kajian pengembangan prototipe pestisida organik. Jadi di sini adalah bahan bakunya berupa tempurung kelapa untuk pembuatan asap cair. Ini adalah contoh dari alat produksi pestisida organiknya, dan ini adalah contoh dari filtrat asam cair, dia masih grade 1 karena warnanya masih coklat. Ini setelah dikemas, kita memberikan namanya sebagai pestisida organik likoris. Selanjutnya, mahasiswa MSc B Batch 3 melakukan pengamatan terhadap perlakuan yang sebelumnya dilakukan uji dulu di laboratorium. Dari kelima cendawan patogen ini, mana yang paling efektif konsentrasi pestisida organiknya? Apakah yang 0% itu kontrol, 10%, 15%, 30%, 20%, atau 25%? Nah, di sini kematian fungi patogen itu berhenti di konsentrasi 15%. Sehingga konsentrasi ini yang kita jadikan sebagai acuan untuk penggunaannya nanti. Untuk tahun ini saya sedang berupaya untuk menurunkan konsentrasinya, jadi ingin mencari ekstrak tanaman yang dapat meningkatkan nitrogennya, namun untuk senyawa aktifnya tetap bertahan di fenol. Kemudian setelah itu dilakukan pengukuran ya oleh mahasiswa MSc B. Jadi di sini kami mengajarkan bagaimana mereka menilai gejala penyakit, menghitung seberapa persen efektivitasnya, seperti itu. Berikut adalah hasil kandungan dari prototipe tersebut, di mana kandungan senyawa bioaktifnya itu mengandung senyawa fenol ya, mengandung senyawa fenol yang memang merupakan senyawa antibiotik, antifungal yang dapat membunuh patogen-patogen. Ini adalah contoh dari analisis datanya. Jadi kita menggunakan SPSS seperti itu. Di sini kita menilai konsentrasi mana yang paling baik dan juga menghitung intensitas gejala penyakitnya. Ya, seperti ini. Jadi kita mencoba untuk menggunakan tanaman yang sakit yang diserang oleh virus dan juga ada yang diserang oleh kutu daun atau kita sebut sebagai trips. Di sini diujikan satu adalah perlakuan menggunakan pestisida organik dan satu lagi adalah kontrol. Kemudian nanti kita hitung berapa penurunan indeks gejala penyakitnya. Di sini juga ada proses bagaimana cara membuat chart dari daun yang sakit seperti itu. Yang kedua adalah kajian sosial terkait proyek aktivitas CPRN 1, Coping Strategies of Urban Households to Ensure Food Security During COVID Pandemic. Ini adalah kerjasama dengan Filipina untuk terkait ketahanan pangan ya di era COVID seperti itu. Jadi di sini kita juga mempelajari tentang data kuantitatif, data kualitatif, kemudian penyusunan policy brief itu seperti apa. Nah, ini adalah contoh dari kegiatannya. Kemudian selain melakukan kegiatan sains juga yang terhubung dengan social research, kami juga telah melakukan satu regional workshop on the inclusion of biodiversity in the environmental education curriculum. Nah, ini adalah dokumentasinya. Jadi kita mendatangkan expert dari Jepang, dari Asia dan negara-negara lain untuk saling melakukan transfer sharing knowledge seperti itu. Dan tentunya melibatkan keterlibatan mahasiswa di sini. Selanjutnya adalah penguatan agro-eco-edutourism, yaitu pembuatan Biotrop Science Technology Expo. Nah, ini adalah perancangan di Biotrop sedang ingin melaksanakan agro-eco-edutourism seperti itu. Nah, ini adalah contoh dari desain interior dan juga eksteriornya. Ini yang interior, nah ini setelah didesain eksteriornya ya dengan menggunakan wallpaper dinding seperti itu. Sedangkan untuk roadmap tahun 2023 untuk Save Biodiversity for Future Generation, kami ingin melakukan pengembangan platform biotrop klinik atau kita sebut sebagai bionik, kemudian pengembangan fertilizer. Selanjutnya untuk section yang lain di biodiversity ranking dan database from mountain to the ocean, mereka ingin melakukan pengembangan terkait metode perankingan biodiversitas, sistem digital database, biodiversitas tropis untuk kingdom plantae dan animalia. Kemudian untuk agro-eco-edutourism, pengembangan produk inovasi dan teknologi. Nah, jadi nanti produk-produk yang diciptakan oleh ITS itu akan dikembangkan di agro-eco-edutourismnya untuk sebagai model pembelajaran bagi mahasiswa ataupun siswa-siswa yang ingin berkunjung ke Seameo Biotrop. Kemudian juga ada pendampingan pengembangan program pembelajaran bidang biologi tropika. Nah, selain melakukan kajian, Biotrop juga memiliki dua bentuk publikasi, satu dalam bentuk jurnal, itu kita sebut sebagai biotropia, yang sudah terindeks Scopus, seperti itu. Tahun lalu Q2, namun turun jadi Q3 gitu ya, jadi harus tetap improve. Selanjutnya ada majalah Science, kita sebut sebagai Biodiverse. Di sini jika artikel mini research mahasiswa itu sekiranya kompeten, itu biasanya kita publish pada majalah ini. Ini sudah memiliki ISSN seperti itu. Ini adalah contoh mahasiswa magang saya ya di MSc B3. Nah, ini adalah kegiatan-kegiatan yang terkait dengan gejala penyakit. Ini adalah mahasiswa magang reguler yang terkait dengan mikoriza, seperti itu. Ini adalah contoh-contoh dari website yang bisa adik-adik kunjungi, seperti itu. Iya, demikian dari saya. Jika nanti ada yang ingin terkait pengajuan magang, bisa dikirimkan ke email administrasi di gau@biotrop.org. Sedangkan untuk publication ke kmd@biotrop.org. Demikian penjelasan dari saya. Terima kasih.
Well, thanks, Ms. Risa. Actually, I regret that there is no educational student here because the program that shared by Ms. Risa is also can be done by educational biology or educational departmental as well. Yeah. Well, okay, but it's okay. Now we move to the next session. It will be question and answer or discussion session. I will open two sessions if it is possible. I will consider the time as well. But for the first session, I will open only two questions. Yeah. So please raise your hand. Yeah. The first is Bu Eli, and the next. Yeah. The next is the next. Yeah. The committee, please. Can you give the microphone to Bu Eli and also other students?
Assalamualaikum warahmatullahi wabarakatuh. Okay, good afternoon, all the speakers. Thank you very much for the fruitful presentation. My name is Eliana Wati. I'm from Physics Education Study Program. And thank you, Prof. Stephen, for the fruitful. Actually, I'm very interested with your talk about the EA. And this semester, I teach my student in the WAVE subject. In this subject, I pursue the student to do their inquiry approach. So they have opportunity to conduct their own practicum by set the purpose, set the procedures, as well as how they collect the data. But the problem is after they conduct their procedure and get the data, they don't know how to analyze the data, since what they do is out of the theory. So they do not only to prove the theory, but as well also how to find something out of the theory that already conduct in the school setting. For example, when doing the pendulum that you already said, that's the regular what we learn in the school or in the classroom. But what they do in the laboratory is connecting two spherical objects and then rolling with a certain surface. So when we apply the formula, perhaps we should consider another variable. No, I think that if my student learn about the AA, as you said, by applying del E or something like that, it would be easier for them to analyze the data. But to overcome this situation, I suggest the student to use the software tracker. So they have to record all the practicum process and then to convert by this application. So they will get the formula. But after get the formula, they don't understand what is the formula means. So perhaps you can give me suggestion what kind of procedure I can apply to the student to overcome this obstacle. Okay, and the second is from Miss Risa. Okay. Yes, interesting. Even though I'm not in biology, I don't have any kind of biology background, but I myself wondering, did any opportunity for my student, because you know that one of my subject is physics, environmental physics, that very connecting with the environment. You know that my student has already learned about how to conserve our environment by providing the community service, understand and observe what happened to the community and what can they do to overcome like the pollution, something like that. So is there any possibility for students to learn about that in your domain? Okay, I think that's all. Thank you very much.
Yeah. Since the question is quite long, so maybe it will be better if you answer the question right away. Yeah, maybe the first Stephen, you can answer this question.
Okay, so my task is very difficult, right? Answering very quickly. Okay, so first of all, I mean, this is a real problem. Data analytics is complicated. Actually, if you want to be prepared to do data analytics, you have to take the statistics classes, you know. So you have to go back to the modules of statistics from, you know, your math department to really understand what the result of the algorithm tells you. So I would suggest first that you ask your student to, you know, go back and open their statistics book, you know, before they try and think that there is something magical in the system. The second point I mean, that point you are making is actually a point that everybody is making. You have heard that one of the great questions now about machine learning and artificial intelligence is explainability, the capability to get the result, yes, but then in order to, you know, take responsibility of the actions that you are going to take based on that results, you need the system to be able to explain how it came to the result. Yeah. So this is still an open issue. Okay, this is still an open issue. So I don't have a magic recipe for you, but what I would suggest is to start by asking the student the simplest data analytics method that exists, the linear regression, the logistic regression. You know, you train them to use these methods to figure out when they are applicable and how to interpret them. So this is a long way to the solution, but it starts from understanding the statistics and the probability theory behind those machine learning methods. But you're not the only one. Everybody is facing this problem. Yeah, thank you.
Oke, baik Ibu. Terima kasih untuk pertanyaannya. Kalau untuk yang terkait dengan mahasiswa dari fisika, dalam program MSIB yang bersertifikat, itu di subbidang magang yang saya ampu yang terkait pengelolaan lahan suboptimal, di sana saya juga mengajarkan tentang kesuburan tanah. Nah, biasanya juga saya menerima Bu mahasiswa fisika karena di sana kami juga melakukan restorasi lahan suboptimal, itu kan terkait 3 ya, selain dari biologi, kimia, dan juga dari fisikanya. Dari fisika dapat diajarkan terkait bagaimana cara melihat tekstur tanah, kemudian kita bisa menghitung permeabilitas melalui pori-porinya itu setelah perlakuan ataupun sebelum ataupun setelah perlakuan. Kemudian juga bagaimana teknik untuk menghitung penyiraman yang baik. Karena kan kalau dia melebihi kapasitas lapang atau airnya rembes ke bawah, itu akan mempengaruhi pertumbuhan tanaman, seperti itu. Jadi yang diajarkan mungkin yang aplikasinya mudah dan efektif dan mudah diterima untuk mahasiswa. So untuk fisik, chemistry, or biology, we open to accept the students to join with us in our independence internship program. Thank you.
Well, yeah, the next question, maybe one question left, yeah, because I have not know the next question for the student.
Okay. Assalamualaikum warahmatullahi wabarakatuh. First, maybe my English is so bad, so I use translate. My name is Mailina. I'm from the Department of Computer Science. I would like to ask Prof. Stefan. So I want to ask you, I'm currently doing some research and still learning. I want your opinion as an experienced person. What do you think about using artificial intelligence like ChatGPT in a good research process? Because we see that there are many myths of it. Thank you.
So maybe two answers, two possibilities. One possibility is to do research on ChatGPT, how it works. That's the first thing, which I think as a computer scientist, you could be interested in. Building large language models on your own. Some of these models, not ChatGPT, but some other models are publicly available. So you can try them. The only thing you need is, and you need to talk to the faculty here. I don't know if you have a general purpose graphic processor. So these big, computers. Actually, maybe some of your friends have, because these are the computers that the people playing games are using. So we use the same computers to do a lot of processing for AI. So if you want to do this kind of research on how ChatGPT works, you can do that. But maybe there's another aspect to your question, which is how can we use ChatGPT to do computer science research or any other research, as a tool. The way I see it now is that ChatGPT can be used as an idea generator. So never take any answer of ChatGPT for the ground truth. We know that ChatGPT can, maybe you heard the word hallucinate, which means dream, right? It dreams the answer. It tells us something which is absolutely not true. But yet, as human beings, we know that sometimes we go to bed, we dream. Maybe it's not true, but it gives us some good idea, right? And the next day in the office, we work on this idea. So maybe this is the way we should use ChatGPT as researchers. Ask for some dreams, and then we bring them to the office or to the lab, and we work on these dreams. So it's an idea generator. You can use it to give you a basis on which you're going to work on for your computer science program. By the way, ChatGPT can write code pretty well. So that you, of course, you need to check the code yourself, but it saves you a lot of time. So at the very least, ask ChatGPT to write the basic code for yourself. This is a good idea. Yeah. Thank you.
Well, unfortunately, our time is over. So I am so sorry because I cannot open the next session. We will finish the session and we reach the end of this session. Thanks. I would like to thanks to the speakers who already explained everything, and it was a great explanation. Yeah. And also I will thanks to the participants who actively join this event. Yeah, we will see next time, I hope. Yeah. Last but not least, wassalamualaikum warahmatullahi wabarakatuh.
Okay, for furthermore, there's a distribution of certificate for both speakers. Thank you very much to Ms. Lutfia Nur Hadianti, SPD MPD, as a moderator who led the seminar session. And also, we would like to say thank you very much to our outstanding speakers, Associate Professor Stefan Preson, PhD, and Ms. Risa Rosita, SSE, MSE, for the time and material that is beneficial for all of us. Hopefully, we can apply it in our campus life, especially applying and developing disciplines and also the collaboration of various disciplines so that our campus will be getting brighter in the eyes of the world. Please give a round of applause to our great speakers and moderator. Okay, well, ladies and gentlemen, it is really interesting and we do really enjoy the seminar session. But because of the time, we've come to the end of the event. We would like to say thank you very much for all of the participants that has attended and followed the entire agendas for today's event properly. I'm Monica, representing the committees. Apologize if there are any mistakes during this event. After this, there will be a documentation session. So after the closing session, I hope that all participants will not leave the event just yet. Well, ladies and gentlemen, let's close our event today by saying Hamdalah together. Alhamdulillahirabbil alamin. Thank you very much, ladies and gentlemen, and see you around next time. Wassalamualaikum warahmatullahi wabarakatuh.